Concept 2 is on scientific notation. Now, some of you have seen scientific notation and some of you have not. Scientific notation is generally used when there are very large or very small numbers that have a lot of zeros. Okay, when we have a lot of zeros, they can get very confusing. So we use scientific notations to make it a little bit less confusing for us. Alright, a scientific notation has two parts. The first part we mentioned in concept 1 is called the mantissa. Okay, and that is a number in the front of the scientific notation. It must be a number between 1 and 10. Okay? The second part of a scientific notation is called a characteristic. The characteristic is the exponent that is on the 10. Alright, so looking at these three examples, what are the mantissa and the characteristic in these? In the first example, 4.032 is the mantissa, and the 6 is the characteristic. Okay? 6.02 in this second example is the mantissa. The 23 is the characteristic. And in this third example, 4.511 is the mantissa. And the negative 3 is the characteristic. Okay? Now I want you to notice that each of these mantissas is between 1 and 10. Okay? And also the characteristics can be a pretty small number or a pretty big number, and it can be a positive number or a negative number. Now there are three things I'm going to expect you to be able to do with scientific notation. The first thing is converting a standard number into scientific notation. So to do that, the first step is to move the decimal in the mantissa until you have a number between 1 and 10. You're going to keep the same number of sig figs. You're going to write times 10 right after the mantissa, and you're going to add a characteristic that will move the decimal to the original number. Okay? This is what you need to do. You need to count how many places the decimal was moved, and if you move the decimal to the left, the characteristic is going to be positive. That means that your original number is a pretty big number. If you move the decimal to the right, then the characteristic is going to be negative. And that means that your original number is a pretty small number. So let's look at examples. Number 1, 17,600. The original decimal point is after this 0. We're going to have to move this decimal so that it is a number between 1 and 10. And what we get is 1.76. Okay, we're going to write times 10 after that. And let's see, we have moved this decimal 1, 2, 3, 4 places. And we have moved the decimal to the left, so the characteristic is going to be positive 4. Number 2, 0.0043. This original decimal point right here, we're going to move it to the right so that it moves to 4.3. Again, this mantissa is between 1 and 10. Okay, write down times 10. We've moved the decimal 3 places, and we moved it to the right, so your characteristic is a negative number. Pause the video and try number 3 and number 4. When you are finished, come back to the video and check if your answers are correct. Number 3, 61,500. When you convert it correctly, you should get 6.15 times 10 to the 4th power. And for number 4, 7.34885. When you convert it correctly, it'll be 7.34885 times 10 to the 0 power. Number 4 is a very interesting case. Notice that the original decimal is already where the mantissa would be a number between 1 and 10. So we don't need to move it anywhere. Okay? So since we are not moving it anywhere, the characteristic is a 0. The second thing I'm going to expect you to be able to do with a scientific notation is to convert scientific notation to a standard number. So to do this, you're going to first look at the characteristic. You move the decimal to the right if the characteristic is positive. And you move the decimal to the left if the characteristic is negative. Notice that this is the opposite of what we did before. Okay? And the second step is basically keep the same number of sig figs as the mantissa. So looking at examples, number 9, 2.24 times 10 to the negative 3 power. This negative 3 tells me to move the decimal to the left 3 places. So we're going to do this. 1, 2, 3. That means I'm going to have 2 zeros in front of the original 2. Okay? So it'll be 0.00224. Look at number 10. 4.5098 times 10 to the 4th power. This characteristic is positive, which means I'm going to move the decimal to the right. 1, 2, 3, 4. And the answer is 45,098. Try number 11 and 12 by yourself. Pause the video and then come back when you are finished to check your answers. The correct answer for number 11 is 1,090. And the correct answer for number 12 is it will be 3,640,000,000. Okay, so there should be 7 zeros after the 364. The third thing that I'm going to expect you to be able to do with a scientific notation is to correct an incorrectly written scientific notation. Okay? So the first step that you're going to do when you're asked to correct a scientific notation is to move the decimal so that your mantissa is a number between 1 and 10. Second step, write times 10. Alright, step 3. If the mantissa increased after you move the decimal, then the characteristic has to decrease by the same number of places. Okay? If the mantissa decreased, then the characteristic has to increase by the same number of places. And finally, keep your sig figs the same as the original number. So looking at number 17. Number 17 says 8,443 times 10 to the second power. You can see that it is incorrect because the mantissa is not between 1 and 10. Okay, so its original decimal is after the 3. We have to move it to between the 8 and the 4. So your new mantissa will be 8.443. Alright, now this is where we have to look at if we do step 3 or step 4. Okay, from 8,443 to 8.443, it looks like we decreased. So if the mantissa decreased, then the characteristic increases. It decreased by 3 places, so we're going to add 3 to the 2. So what I would get is 5. Number 18.0025 times 10 to the 64 power. This decimal needs to be between 2 and 5 to make it a number between 1 and 10. So our new mantissa will be 2.5. From 0.0025 to 2.5, it looks like we increase the number. So if we increase the mantissa, the characteristic must decrease. By how much? Looks like we moved it 3 places, so we're going to subtract 3. 64 minus 3 is 61. Let's try a few more together. Number 21. 54 times 10 to the 7th power. The original decimal is after the 4. We need to move it so that we get 5.4. Okay, from 54 to 5.4, we have decreased the mantissa by 1 place. So we must increase the characteristic by adding 1. So it would be times 10 to the 8th power. And one last one, number 22, 0.00002631. Looks like we have to move this decimal 1, 2, 3, 4, 5 places so that we get 2.631. Okay, we have increased the mantissa, so the characteristic has to decrease by 1, 2, 3, 4, 5 places, so we must subtract 5. 4 minus 5 is -1.